Hi, this is King of Review. Working together, it takes Andrew and Brian 6 days to finish a job. If Andrew works 3 days and then Brian works to complete the rest of the job, it takes Brian 8 days. How many days will it take Andrew working alone to complete this job? So what we want to do is set up a couple of equations that represent this situation. And before we do that, we need to define our variables. So first off, let's let 1 be the total amount of the job. So 1 is equal to the total amount of the job. And let's let x equal the amount of the job that Andrew can do per day. So the amount of the job that Andrew can do per day. And for y, let's let y equal the amount of the job that Brian can do per day. So now we've set up what our variables are. Now we need to piece together an equation, 2 equations for this. So let's see here. It takes Andrew 3 days. If it takes Andrew 3 days to do the first part of the job, and then it takes Brian 8 days to do the rest of the job, together it takes 8 plus the 3 days to get the total amount done. So how can we represent this? Well, 3 days times the amount of work that Andrew does per day. Again, remember, we let that amount be equal to x, so 3 times x, plus 8 times the amount of the job that Brian can do per day, and that's equal to y, so 8y. And what does this equal? Well, that equals the total job being complete, and we're letting that equal 1. So 3x plus 8y equals 1. Now let's make another equation. We're told that it takes them together 6 days to finish the job. So again, to complete the job here, we're writing a 1 for the total amount of the job being completed. So it takes them 6 days together to complete the job. So this would be 6 days times the amount of the job that Andrew can do per day. That is represented with an x, plus 6 days times the amount of the job that Brian can do per day, and that's y. So 6x plus 6y equals 1. That equation represents them working together for 6 days to complete the job. So we have our system of equations here. We have 2 equations and 2 variables. And you can see that these equations are in the form ax plus by equals e and cx plus dy equals f. So we want to solve for x and y. And we can do this using a method called Cramer's rule. You can use Cramer's rule, which uses determinants to solve a system of linear equations. And that's what we want to do here. We want to solve this system. So Cramer's rule says that we can solve for x by taking the determinant of the x matrix and dividing it by the determinant of the coefficient matrix. And for y, this is equal to the determinant of the y matrix divided by the determinant of the coefficient matrix. So let's set up our 3 matrices. We'll first look at the coefficient matrix. Well, the entries in this matrix, those are going to be the coefficients of our x and y terms, so a, b, c, and d. The x matrix, the first entries are going to be e and f. And if you look over here, e and f are the constants of the 2 linear equations. And then the other entries are b and d. And the Y matrix, this is equal to ACEF. So this is how we set up the matrices. So let's fill out our matrices with our specific values. Let's start with the coefficient matrix. What are the coefficients in our system here? Well, we have 3, 8, 6, and 6. So 3, 8, 6, and 6. What about the X matrix? We start with E and F, and those are the constants, so 1 and 1. And then we have B and D, so 8 and 6. And for Y, we have A and C, and then E and F. So now we've set up our three matrices, but you see over here, to solve for X and Y, we actually need the determinants of these matrices. A determinant is a real number associated with a square matrix. So let's say we have a matrix with entries A, B, C, D. To find the determinant, we're going to take the product of the main diagonal, so AD, and then we're going to subtract the product of the entries in the other diagonal, CB. So we have AD minus CB. This will give us the determinant. So let's find the determinant of our coefficient matrix. We're going to take the product of the main diagonal, so 3 times 6, and subtract the product of the entries in the other diagonal, so 6 times 8. So we have 3 times 6 minus 6 times 8. And when we work this out, this is going to give us 18 minus the 48. And what does this equal? If we have 18 minus 48, this is going to equal negative 30. And now let's figure out the determinant for the X matrix. We take the main diagonal, so we have 1 times 6 minus the entries in the other diagonal, minus the product of those entries, so 1 times 8. So this is equal to 6 minus 8, so we have a negative 2 here. And now let's determine the determinant for the Y matrix. So we take the product of the main diagonal, 3 times 1, minus the product of the entries in the other diagonal, 6 times 1. So we have 3 minus 6, and that equals negative 3. So solving for X, we have the determinant of the X matrix. Well, we solved for that here, that's negative 2, divided by the determinant of the coefficient matrix. Well, that's negative 30. So we have negative 2 divided by negative 30, and when we reduce this, this equals 1 over 15. So we know that X is equal to 1 over 15. And now let's find Y. We take the determinant of the Y matrix, we solved for that here, that's negative 3, over the determinant of the coefficient matrix, that's negative 30. And when we reduce this, negative 3 over negative 30, we get 1 over 10. So we have Y equals 1 over 10. Now, what did these represent? Well, X, what was that? Let's look back up here. X is the amount of the job that person A can do per day. So this is Andrew. This is the amount of the job that Andrew can do per day. And what about Y? Well, Y represents the amount of the job that person B or Brian can do per day. So this was Brian. What does the question ask for? How many days will it take Andrew working alone to complete the job? Well, let's see here. We know that in one day, Andrew can do 1/15 of the job. So he gets 1/15 of the job done every day. So in order to get the complete job done, this is going to take him 15 days. So 15 days for Andrew. And this is the final answer here, 15. Thanks for watching.